Alright guys, welcome to Algebra 2. This is 2.1.1. So this would be a lesson where we do a lot more of a in-class lab type thing, but we're not going to be able to do that just because of circumstances and this being a more a video thing here. So we're going to kind of do it in a slightly different way. So what we normally would do here is we get a piece of cardstock and we have concentric circles drawn on it, and we're going to cut out rings that kind of gradually get smaller and smaller and smaller. And we're going to weigh those. So basically we're trying to weigh a circle of different radii and seeing, well, how does the weight or the mass of it change as I reduce that radius down. So we're going to kind of translate that into just being able to do it in our heads, because if you think about the volume of it, the thickness of the cardstock is never going to change. So the only thing which is really going to change is going to be the actual area of the circle. So we can kind of try and remodel that and say, well, how is the area going to change? So when we're looking at the actual problems here today, kind of replace the mass or the volume with just the area, and we're going to get effectively the same result out of it, because like I said, that thickness is going to remain constant throughout the entire problem. So we're going to kind of translate it to that so that it's a little bit more user-friendly for these circumstances. So I'm not going to go through the entirety of the problem here because it kind of goes through a lot of step-by-step things, but if I were to try and get an equation that is going to model my area given what my radius is, you probably already know what that equation is, right? It's going to be that pi r squared equation. Now, if I try and put that into like a Desmos or some kind of graphing utility, it's a little bit more challenging because I can't just put an r, so I have to convert that r to an x. So I'm going to go ahead and hop over to a Desmos window here. And on this, what I want to do is I'm going to actually make a table. So if we were to actually go here and measure this, I'm going to, easiest thing is to get rid of these little ones. I hate how they put the little ones there, but they do. And then over here, I'm going to change that into just being pi r squared, or I'm going to give, in this case, pi x squared. So you can just type in pi and then x squared. So now what it'll do is it'll take whatever radiuses that I have here, and it'll plot them, and it'll give me the resulting area over here. So I'm going to start off with like -2, and then -1, and then it should start to kind of autofill in here. 0, 1, 2, 3, 4, 5, 6, 7. Let's go to 8. Okay, so we're getting some pretty large numbers there once we're at 8. So it's really hard for me to kind of see these on my graph here. So I'm going to go over here and graph settings. I'm going to make my x-axis go from like -5 to 10. That's good. And then my y's, I'm going to go from -1, because I really don't go negative here ever. I'm going to go all the way up to, let's do like 225. I should see all those points there now. So I can definitely see the shape of my graph, and this is quite clearly a parabolic shape, or a parabola for me. Which makes sense because I'm just doing pi is just some number, so it's some number times x to the second. That's going to be a quadratic or a parabola when I graph it. So there we go. What I want to focus on primarily, though, is I want to head back over to this, and let's take a look at problem 2. So problem 2 is where I start to kind of care a little bit more about what we're getting from this result. So part A, what are all of the acceptable input and output values, the domain and range for the activity? So let's think about what that means. It's saying, hey, on this equation, right, so if I hop back over to Desmos, there's a lot of stuff here which I could plug in. I could keep plugging in negatives. I could go even bigger here, but like kind of what makes sense, right? Well, my x is really my radius. Does it really make sense to have my radius here being negative? Well, no, right? The smallest radius that I could get would be 0, right? Even that's kind of like, well, would I really care about 0? Well, no, but it's still kind of a fine place to like start, because you theoretically can have a 0 radius circle. It's just nothing, right? But you can't have a negative radius circle. So what I would say is, well, my domain here that makes sense for the context is going to be 0 and bigger, even though my domain for the equation would be all real numbers. Right, this is the thing that we're going to try and take our next step towards. Being able to know what the radius, what the domain and the range are for an equation is kind of nice. The thing that you're going to care about way more is going to be what is the domain and the range in the context of the problem. So in the context of this problem, my domain is going to be 0 and larger. So it could be 0 or it could be any value larger than that, because I could have my circle get theoretically infinitely large, so I could have any number of size radii so long as it's larger than 0. Now how about the range? Well, my range-wise, 0 is going to be the smallest area that I could get, and then I can only get positives out of that, right? I can't have a negative area, one, because that doesn't make sense logically, but two, looking at my equation, pi is always positive, and then x to the second, whenever I'm squaring things, it'll always make them positive. Positive times positive, it's always going to be positive, so long as it's not 0. So my domain is going to be 0 and larger. My range is going to be 0 and larger for this particular problem. All right, let's hop back over to this. So part B, in part A, you may have noticed that your equation may only make sense for a model for as a model 3 data on part of its domain. Therefore, to accurately describe the model, you can add a condition to your equation, such as this equation is a good model when, in our case, x is 0 or larger, right? These are what's called domain restrictions. We're going to get into that a little bit in the future, but it's things which you've seen in the past. Like I said, hey, here's this equation, and they'll have like a little comma, then hey, x is not 1, or x is not 0, or stuff like that. Those are domain restrictions, saying, hey, this model works, except for this case here where it doesn't, but it's good everywhere else. So that's why we can't have those. So like here, our model was really good, right? It was good, but only when it was 0 and larger, because it's not like it's a bad model, but it's not a useful model when I'm in that negative values as far as x's go. So that's why we're going to start to kind of see those. And then part 3, not really going to be relevant for us because we didn't physically go and do that first part as it normally would be. So note-wise, here's some quick notes on exponential functions. So I'll let you guys go ahead and read through those and take down notes as you feel fit. But this is mostly stuff you've probably seen a bit in the past. Things that I want to point out are the initial value and the multiplier. Those are just terms you've kind of seen quite a bit. So make sure you know kind of what each of those parts mean in the context of both the graph and the equation. But again, read through that. If you feel like you need more notes on it, then go and take them. Otherwise, you're probably good. So closure, it's about transforming x to the second. So if I want to move that to the right, if I want to move that to the left, what I end up doing is I put parentheses around the x, and then I make it like x minus 2 or x minus 3, and then I square it, and that'll move it to the right. If I put like x plus 2, it'll move it to the left. And then if I want to move it up and down, I can add to the outside of it here. And if I want to kind of stretch it vertically, I can multiply on the front of it. I can also put a negative there, and that'll flip it over. Those are the main things you should have kind of seen at least a little bit in the past. We're really going to go over those more and more kind of coming up. So if those aren't second nature right now, that's totally fine. We're going to go over it more kind of coming up. So with that, here is our homework for today. It's going to be 4 through 10, and I will talk to you guys next time.